In this video, I will learn a pile cap foundation, design of a pile cap foundation of a multi-story building or single-story building or any type of uh, building or any type of structure. Now click on Open Project. Pile cap. This folder is created by me and analyze the results of a reinforced concrete building is saved here before by me. Open it. Post-processing results are available. Okay, now we see them. Now the analysis of a multi-story building is completed. Now I will design its footing and I will make the footings by means of pile caps. We use pile caps, because piles under the foundation, because the robust or the soil with the enough load bearing capacity does not exist beneath the footing or beneath the building. It's very far away in vertical direction, away from the footing, and to put our building and its footings on the robust or on the robust foundation or rock or any type of soil which has sufficient load bearing capacity, we have to connect this type of rock or good soil. We have to put some piles between footing and this type of rock or robust soil. Okay. I couldn't illustrate or I couldn't explain it good. That was my intention. For example, I have a footing and I have a soil here. Let's say I have a soil here. The soil beneath my footing is very weak. It's clay, for example. Okay, composed of clay. Or any type of bad soil which does not possess enough load bearing capacity or could be affected from water and could swell or shrinkage and change its volume because of water effects and some other effects, and we can't put our replace or construct our building on the soil. So we have to before building our constructing our building, we have to construct piles. There are also columns, something like that, which is a connection between the robust rock or the soil which has sufficient load bearing capacity, and by means of those piles we can put our footings and, by the way, our building direct on this robust soil or rock material. And of course this time be it all footings, you would have maybe more than one pile. So this type of footing is called as pile cap. In general, these are continuous, and the piles has a cap, and all piles are connected to each other at their tops by means of this cap. It's a continuous beam. Now let's look here to, I want to design the footing using the pile and the cap of the pile. Click on the foundation design, include all the load cases, and I will design all the supports. Supports are the foundations. Foundations, or foundation can be used sometimes in the literature for soil, sometimes for the footing. Let's say I will design all the footings, and for all load cases I have just one load case here. Always click on include all here. If you have other load cases, include all of them. Randstad foundation. Now we are calling the Randstad foundation from inside of Step Pro. Now in the geometry menu we see the geometry of our footings. We have nothing to do with this data input pane. You can close it. Now first of all, what we have to do is generate load combinations. Select the standard. I select ASCII standard, American standard, to obtain the load combinations for the service limit analysis and the strength limit analysis. The load combinations created for the service limit analysis will start with the number 101. For the strength limit analysis, there will be new load combinations generated, and they will start with the number 201. Generate both of them. As you see here, 3 load combinations are generated. We have nothing to do with this anymore. And come to the job setup. Create new job. Write here pile cap. You can also write pile footing. This is a user-defined name. It's pile cap. Default unit is SI unit. Assigned to all supports. Available load cases, we are using only the combination load cases for the service and strength limit analysis. Create the job. Now the job is created, it's here. We have design parameters. You see, pile cap is something. This is the cap of the piles. There are a lot of piles. It's the cap of the piles. And merhaba. So, somebody entered to my room, that's why I made a pause. Now, strength of the concrete. Strength of the concrete. Now, let's look to the definitions. Now, open. Sorry, cancel. Design parameters form for pile cap. I copied this information from the help of the program. We can reach it from here, from help, from contents. We can make a search and anyway reach to this information. I reached it and copy paste it to here. Now design parameters. The explanation of design parameters are given is strength of concrete. Specify the ultimate strength of concrete in the selected units. Now one might think that the concrete is same for the cap and for the pile, or can we use different concrete strength, different concrete type for the pile and cap? I think the same concrete type is used for the cap and the pile. So the concrete strength entered here is the strength, compressive strength of concrete for the piles and their cap. The weight of the concrete is entered here. The yield strength used to construct the pile cap is entered here. Side cover is the concrete cover. Side cover, CS. Specify a concrete clear cover distance to be used for the sides of the pile cap reinforcement. That's the pile cap, and these are the piles. So this distance CS is the side cover. So bottom cover is CB. As you see, this distance. The distance is the distance between the bottom reinforcement in the cap and the top point of the pile. That's the bottom cover. Pile in the cap. What is pile in the cap? Pile in the cap has a symbol CP. CP. We can see it here. So the distance here, okay, the distance of the pile in the cap is given here with the symbol CP. So pile in the cap is CP. We learn it from here. The distance from the bottom of the pile cap to the top of the piles. So this is not called as cap, it's called as pile cap. The distance between the pile cap or the cap of the piles or piles cap, that's the CP distance, pile in the pile cap. Yeah, as you see here, the pile portion in the pile cap. Initial thickness, the minimum thickness used in design. This minimum thickness, there is no symbol is used here. I guess it is the thickness of the pile cap or the cap. I prefer saying on the cap to not to confuse it with its piles. Set as default, minimum maximum bar spacing. Specify the minimum maximum distances to be allowed between reinforcement bars. This distance, the distance between two reinforcement bars. If you change those values, and then if you want to set them default, and when you open the program, if you want to start using the values, you make changes here. Set them as default. So select yes to make the values you entered here as default values in the program. That's it. So I don't make any change here. C25 megapascal, unit weight of concrete, okay. Yield strength of concrete, okay, I don't change anything about them. Pile layout, to make the design and to make the configuration of the piles beneath its pile, we have to make some configuration. We will use this tool or this tool. I use this tool. Pile arrangement for support. Now we design for support one. How many supports do we have? Support means footing here. Number 1, number 19, number 20, number 37, number 2, number 20, 38. In total, I have 9 footings. So I have to make design for all of them. Starting from the first footing, the pile capacity. The pile shall has any capacity to carry the footing, to carry the loads coming from the footing, and the load takes the loads from the superstructure, the building, column, beam, floor, etc. And the pile has the duty or the task to transfer these loads which are taken from the cap to the robust soil. Sorry about my English.
Week, making sure that the system was robust enough and testing it,
Robust.
and then
They say robust. They say robust. Okay. Robust soil. So the duty of the pile is to transfer the loads taken from the cap to the robust soil, which might be a rock. And the pile shell has capacity, its vertical capacity. This is the capacity to carry the vertical loads. This is the capacity to carry the lateral loads. This is the capacity to carry the uplift loads. If any tension vertical force acts to the footing, this will try to pull the pile from the soil. So against that, The pile shell has also uplift carrying capacity. Those values depend can be taken from the pile manufacturers. Okay, and the pile diameter, pile spacing, its edge distance are entered here. The explanation of those things are explained here. Using this tool, the pile arrangement for a pile cap using a set of predefined pile layout. We will see there are a lot of predefined pile layouts under cap. We will make the design of pile and pile cap. Using the predefined layout, the program can automatically choose the best possible pile arrangement. Okay, now pile arrangement for support. Select the support from the current job. Okay, we have started with footing 1. Okay, now let's read the explanation of those things from its help. I extracted this information, those explanations from the help of the program. Pile capacity. The pile capacity group box allows you to input the forces that a pile is meant to bear. Or actually it's load bearing capacity of the piles. Specify the lateral force a pile is meant to bear, its capacity. Okay. Diameter of a pile, it's apparent. Spacing between piles. Edge distance. Distance between the edges of a pile cap and edge piles in the selected units. So, this is the pile cap. This is the pile. Edge to edge distance. This distance. Okay, edge distance. So loading on support opens the load table for support dialog which places total loading on the support for each load case selected under support for pile arrangement. Okay. Show loading on support. Show the loading on support 1, footing 1. Okay. For those load combination cases, we have those loads in global coordinates as far as I know, according to those axis directions. As you see here, My is not taken into consideration. So those are the bending moments. My is the twisting moment or torsion moment. It's not taken into consideration. For example, the maximum vertical force is Fy. It's approximately 1000 kilonewton. That's the loading. Now, come here, pile arrangement type. Select to have the program generate an auto arrangement list or to specify a manual arrangement in that pile arrangement table. The pile arrangement type group box allows you to input the coordinates for a pile arrangement or to have state foundation calculate pile arrangement automatically. Auto arrangement. The auto arrangement radio option allows you to have state foundation calculate the pile arrangement. Pile arrangement table. This table displays the planned distances from the center of the column at local origin to the center of each pile. Okay, understood. When the manual arrangement option is selected, each pile location must be manually entered. This is hard. If the auto arrangement is selected, the table displays the local pile coordinates for the selected arrangement. This is the better thing. This is the only thing that should be done. This table displays the planned distances from the center of the column at local origin to the center of each pile. When the manual arrangement option is selected, each pile location must be there's a mistake here, I can't read. arrangement. Select the table displays the local pile coordinates for the select arrangement. Okay, I understood. I got the point. Now select auto arrangement. Now click on calculate. Select a pile arrangement. Select pile arrangement. This is the cap, and these are the locations of the piles under footing. Footing 1. Under footing 1, I want that piles are arranged. So if I want that more pile, I want 5 pile. How many number of piles you put under a footing, the load carrying capacity is better. You make more robust your footing. I prefer putting 5 pile. Click on OK. As you see now here, the center of the footing is considered as 0, 0 xy coordinates, and then the location of the piles are automatically written to the boxes here. At the center we have one pile, that's this one, and for example at one corner we have with these coordinates a pile, and they are symmetrically distributed to the corners of the footing. Select arrangement. Is there an explanation for this? Select arrangement. There is no explanation for this command. I don't know what happens if I click on it or not. Show pile reactions. We can see the pile reactions here. For load case 1, pile 1 has this reaction, and other cases approximately 150 reaction I have for load case 1. Now show loading on support. For load case 1, approximately 700 is the vertical. For load case 201, approximately we have 1000 vertical force. So divided by 5 pile, every pile shell has to carry approximately 200 kilonewton. So pile reaction, as you see here, for vertical approximately 200. Okay, every of them carries. So 200 is lower than its vertical load carrying capacity, so that's okay. That's okay. So click on design. Okay, our cap is designed. It's closed. No, what happened? But it is closed. So make everything very quickly. Job is created. Design parameters. We didn't touch to those parameters. We understood what they are. We use predefined file layout tool to design our footing one. They are okay. Pile diameter. Those values can be taken from the manufacturer of the piles. Explanation we have done here. Auto arrangement. Calculate. I want 5 pile. Case 1. Case 3. Let's make it case 3. Okay. Select arrangement. And maybe let's click on it. Nothing has happened. Show pile reactions. Let's make the design. Okay. PyCap 1 is designed here. You see its calculations, its geometry, detail and schedule drawing. Detail drawing is provided here. Okay. Schedule drawing. Schedule drawing is only available for isolated and combined footing only. You can save this drawing. There is no GA drawing. We have calculation sheet. There is no graph. So do the same thing for the support 2. Make auto arrangement. Click here. Select case tree. Here. Select arrangement. I couldn't find any information about what that button is. The arrangement is already selected. Maybe to verify that this arrangement is selected by me, click on it. We don't need to see pile reactions. Click on design. That's okay. PyCap 2 is also created. Now as you see, PyCap 2 is also created. And here we will see under PyCap P1, we will see a heading about PyCap P2. Yeah, it's also created. When all of them has finished, print calculation sheet button will be clicked by us and the report can be saved. For footing 3, where is footing 3? 1, 2, 3. Footing 3 is here. Let's make auto arrangement. Select this arrangement. Click on OK. Select arrangement and make design for the footing 3. It's also OK. Footing 3 is here. Select geometry. Continue with footing 19. And auto arrangement, make calculation. Case 3, OK. Select arrangement and click on design. OK. Continue with 20. Auto arrangement, calculate. OK. Select arrangement, click on design. 21. Also make the same arrangement. 37. Okay, all of them are designed. Now PyCap 39, this was the last one. I have 9 PyCap. Its calculations is also done. Detail and schedule drawing for detailed drawing for every footing can be also taken from here using detailed drawing as button. And calculation sheet can be also by clicking pin calculation sheet button can be obtained and saved to your computer. That's the everything. From here, as I understood, the caps are not connected. The program taught every cap separated and calculate necessary pi dimensions parameters for every footing which has rectangular inclined dimensions from my understanding. But in the construction, let's close this. In the construction, in general, many such foundations, for example, consider a cooling tower, an important building. A circular strip footing is a cap, and the piles are then beneath it. As what I want to say is, it's better that the caps or the piles are connected with each other. This is same as for chimney constructions. Consider a chimney. Generally, those structures are thin, slender, and very tall in height, but their foundation is because of the bending moment acting to their bottom. Their foundations is also very large. And generally, mat foundation, I encountered with such a project. They have mat foundation, and so this mat foundation actually is the cap of the whole piles. So all the caps are connected with each other. All the piles have just one cap. Generally, one cap is one huge cap is constructed. I think for a three-dimensional building, if you make a mat foundation, and see it as a pile cap, one single pile cap, instead of designing a single pile cap for every footing beneath every column, construct and design one pile cap and design piles under this one pile cap, which is the mat footing of the structure. In the program, the tool makes design for every single mat footing. Maybe I don't have this version. Using Stat Foundation Advanced, we can design a pile cap composed of which is actually a mat complete footing, and we can then design piles for just one footing, which is the mat footing of the whole structure. This would be a better design solution for any type of structure, which also prevents different vertical settlement of the structure, and also which also provides a better resistance to the lateral dangerous forces like earthquake forces, which acts to the base of the structure in terms of ground displacement.